Hi everyone. Immunofluorescence is a type of in vitro immunodiagnostic assay performed on biological samples to detect a specific antigen using a fluorescent labeled antibody specific to this antigen. It was first described in 1942 and then refined by Coons in 1950, who used a fluorescence microscope for this purpose. Fluorescent dyes are needed for this technique, which are termed fluorochromes, for example, rhodamine, fluorescein, phycoerythrin, etc. These absorb light in the ultraviolet range and get excited. Subsequently, when they return to their ground state, they emit light that belongs to the visible range. This phenomena is termed fluorescence. Immunofluorescence tests are also termed fluorescent antibody test or abbreviated as FAT, FAT. The principle revolves around the facts that specific antibodies labeled with fluorochromes are provided to the sample. When UV light of a specific wavelength falls on the fluorochrome, it absorbs that light and then emits light of another wavelength in the visible range. The emitted light can be then viewed with a fluorescent microscope. The immunofluorescence is of two types, direct and indirect. The direct immunofluorescence test involves the fluorochrome, which is used to label the single antibody which is used as a probe for the antigen. If the antigen is present, this fluorescently labeled antibody directly reacts with it, and any fluorescence showing under fluorescent microscope after the washing step indicates the presence of this particular antigen. The procedure involves fixing of the specimen onto the slide. Fluorochrome labeled antibodies are then added to it, incubation and then careful washing with wash buffers like PBS or phosphobuffered saline to remove the unbound probe, and then the sample is observed under a fluorescence microscope for the presence of the antigen. The uses of it includes the detection of rabies virus antigen in the skin smear collected from the nape of the neck in the humans and saliva of the dogs, and for the detection of various pathogens like Neisseria gonorrhoeae, Clostridium diphtheriae, Treponema pallidum, etc. directly in the clinical samples. The advantages of direct immunofluorescence include that the protocols are shorter and hence quicker, and species cross-reactivity is minimized in direct methods as a single specific antibody is used. Its disadvantages include that antibodies for each antigen need to be prepared for each pathogen separately. Hence, the assay can become expensive, and this protocol is lesser sensitive than the indirect immunofluorescence. Now moving on to the indirect immunofluorescence test. Just like in the indirect ELISA, first the sample is exposed to its specific antibody called the primary antibody, which is unlabeled. A washing step follows, and then fluorescently labeled secondary antibodies are provided to this immunoconjugate. These secondary antibodies are actually anti-antibodies that bind to the Fc portion of the primary antibodies. Since the Fc portion is constant, the same anti-antibodies may be utilized to bind to Fc of any and all primary antibodies, so the same secondary antibodies can be used in so many assays. The procedure involves fixing of a known antigen onto the slide. Then the specimen to be tested is applied to the slide nearby. Exposure of both to primary antibodies, incubation and careful washing with PBS. Then a secondary antibody with the fluorescent tag is added to both. Incubation and careful washing again with PBS, and observation for fluorescence using a fluorescent microscope and determining if the antigen was present. Its uses include in the diagnosis of syphilis, amoebiasis, leptospirosis, toxoplasmosis and many other diseases, and also in the detection of autoantibodies which cause autoimmune disorders. Its advantages are that in case of secondary antibodies, a single fluorochrome labeled antibodies may be used for detecting many antigen-antibody interactions. It is more sensitive than the direct immunofluorescence, and multiple secondary antibodies can also be made to bind to the Fc region of primary antibody, which amplifies the fluorescence signal and empowers the visualization. Its disadvantages include that it is more complex and time-consuming than the direct immunofluorescence. Cross-reactivity of secondary antibody to other agents can also be problematic at times. In the result, if the antigen of interest is present in the sample, a fluorescent antigen-antibody complex is formed that stays on despite the stringent wash, while all other adsorbed antibodies get eliminated. This may be visualized through a fluorescent microscope and the test is said to be positive. On the other hand, if the antigen is absent, all the labeled antibodies remain adsorbed, which get washed off, and the test is said to be negative. Hope this simplified description on immunofluorescence was useful to one and all. We, Brahmjeet and Archana, are extremely thankful to all of you for watching and appreciating. See you very soon with yet another powerful immunodiagnostic. Till then, take care and bye.